All right, guys, we're going to look at central angles and arc measures. So a central angle is an angle with its vertex at the center. Center of the circle, and its two sides are radii. So radii is just plural for radius. So AB and BC are both radius. They'll be the radius, so together plural radii. The sum of all the central angles in a circle is 360 degrees. So if you take all the angles in the center, all of those together would be 360 degrees. All right, an example of a central circle is angle ABC. You can see here, this is a central angle. So the degree of the arc formed by the endpoints of a central angle is equal to the degree of the central angle. So what that's saying is the arc, this symbol here is for arc. So the measure of AC is equal to 84 degrees. Because that's the central angle measure, so the arc would be the same. The measure of ADC is what's left out of 360. So the rest of this would be 360 minus the 84. So that would be 276 degrees. So to find this, you would do 360 minus the central angle, and that gives you the 276. All right, so let's look at some examples using the information we just talked about. So find each angle and arc measure. All right, so when you see the arc, that means we're looking for the arc. When you see the angle symbol, we're looking for the angle. And remember, when you have a central angle, that central angle is equal to that arc measure. All right, so the first one says the measure of JK. So we're looking for that arc measure. We see that the central angle is 21, so we know the arc measure is the same. All right, then we're looking for the measure of angle JNM. So JNM is this angle. Well, we know that the entire circle is 360. These are opposite angles, so they're going to be the same. So 21 and 21. You remember back from Math 1 or Geometry, whichever you had. Now we know that the entire circle is 360, so we can do 360 minus 42, or minus 21 and then minus 21 again, which is 42. So 360 minus 42. And then half that, because this angle and this angle are also congruent. So that means this angle would be 159 and this angle would be 159. Now you can check to make sure you did your math correct, or make sure I did my math correct. If you add these four numbers up, that your central angles should equal 360 degrees. All right, so now it says the measure of angle JNM. JNM, an angle is always 3 letters, and so that would be 159 degrees. All right, and the measure of KL. So arc, the measure of KL, so we're looking for, here's KL, so KL. This arc would be the same as that central angle, so that one is also 159 degrees. All right, now we're looking for the measure of arc JKM. So you may wonder, why does this have 2 and this has 3? If you remember back to your definitions, this would be the difference between your minor arc and major arc. So this one would be less than 180 and this one would be greater than 180. So we're going to go, let's change the colors to make it a little easier. So the measure of JKM, J, here's K, and then M goes all the way to here. So we have to do 159 plus 21 plus 21, or 159 plus the 42. So this angle should be 201 degrees. All right, and then the last one says the measure of arc MKL. So if we go M, you go in the order that it shows right here. So M, then K, then L. So if we go from M to K to L. So basically we got the whole circle minus the 21. So you're going to do 360 minus 21, or you could do 159 plus 21 plus 159, whichever way you want to get to it. So this will be 339 degrees. So basically you're using the fact that the circle has 360 degrees, and you know that the arc measure is the same as the central angle measure. All right, let's look at number 2. So we're given this central angle as 87, and we're given this arc measure as 72. So we need to find out what the missing parts are before we get started. So once again, we know that the entire circle is 360. If the entire circle is 360, we know that the semicircle is 180. Okay, so a semicircle is 180. So we have 72 and 87. We know that this is 72 as well, because the central angle equals the arc measure. And then if we have 180, we're going to subtract the 72 and subtract the 87 to find the angle in the middle. So we're going to have that as 21. So we have that side of the circle figured out. All right, now SXW is a central angle, and so is UXV, and since those are opposite, those are congruent. So I'm going to have 72 degrees there. And then again, this is a diameter. It goes through the center of the circle, so this creates a semicircle. So we're going to have 180 minus the 72. And that gives us this angle here. And again, the arc measures are the same as the central angles. All right, so let's see if we can make sense out of this. So we've got the measure of angle UXV. So UXV, we found that is 72 degrees. And then we need the measure of arc ST. So ST is here, so that would be 21 degrees, same as the central angle. And then we need the measure of WV. WV is here, and that's going to be the 108 degrees. We need the measure of TW. Okay. T is here. W is here, so that's these two arcs together. So the 72 plus the 21 gives us 93. And then the measure of TVW. So here's T, V, W. So we're going from T to V to W. So we've got 87 plus 72 plus 108. And that gives us 267 degrees. All right, if we look at number 3, you see this perpendicular thing here, meaning these two lines are perpendicular, or this creates a 90-degree angle. So when you see that, you know that's 90. And because this is the diameter, this is 180, so this is also 90. And this is also 90. And actually this side is as well, but it's split by a radii. So we're going to say this is 34, so this has to be 90 minus 34. 90 minus 34 is 56. And now we can answer these questions. I'm going to move these lines here. Those don't quite look like 90-degree angles, so I'm going to erase those just to get them out of the way. All right, so now we're going to look for the measure of arc CD. So we're looking for this measure. This is central angle 90. Arc measure would also be 90. All right, then we're looking for FD. So F to D. Okay, when it's only 2 letters, it's your minor arc, so it goes the shortest distance, which would be the 90 plus 34. So that would be 124 degrees. All right, when you see 3 letters, you know it's going to be a major arc or greater than 180. So we're going to do arc DCF. So if we go D to C to F. So it goes from here to here. So we can do 360 minus 90 minus 34. 360 minus 90, 270 minus 34 is going to be 236. All right, and then we're going to look for the last angle here, and the last angle, the last arc measure will be GDF. So arc GDF, so here's G. It's got 3 letters, so we know it's a major arc. So we're going to go GDF. So basically 360 minus 56. So that's going to be 304 degrees. All right, to speed things up a little bit, I went ahead and added these. We have 2 angles here that are made by diameters. So these are congruent angles, 19 degrees and 19. This one is a 90, so we know we can do 90 minus the 19 to give us the 71. This one is a semicircle, so this one has to be 90 if this one is. And then this is a semicircle as well, so we do the 180 minus 19 to get the 161. Now, once we fill in our circle, then you can look and say the measure of arc PQ. PQ is here, so it's going to be 71. The measure of SR. SR is here, so SR is 161. And QRT, that's a major arc, so QRT. So that's going to be the 180 plus 19. So semicircle, 180 plus the 19 is 199. All right, and then we have arc PSR. So PSR, it is a major arc. So PSR. So it's everything but this 90 degrees. So it's everything but 90. So 360 minus 90 is 270 degrees. And then we have a minor arc. So we've got PS. PS is this corner here. If we just back this up to here, this is PS. And PS would be the 90 plus 119. So 90 plus 119 is 109 degrees. All right, we will continue in the next video.